Okay, today's lesson is looking at complementary events. First thing to do, if you haven't done it already, there is a Dr. Nick video which I want you to watch and make notes on with probabilities of events using not or, and also looking at complementary events as well. Watch that video. The key thing is the formulas that you're given, they are the ones that are given in the exam as well. You need to have a good understanding of those. So if there's any questions after watching that video, it's really important you get in contact with me and we can go through, or I can show you it differently so that you've got a good understanding. So if you haven't watched that video, go back to the lesson page. There should be a link above the link that was to this video and complete that. So now that you have a reasonably good understanding of complementary events, I've just got some summary notes here. So you should be familiar that with complementary events, there's two outcomes. It either happens or it doesn't. So a false statistical statement to say that everything in life is 50-50 because it either happens or it doesn't, because the event and its complement aren't always equal. So something that's likely means that its complement is unlikely, and the reverse is true. These events are mutually exclusive, which we'll talk about in the next lesson. And the way we notate looking at an event A is that we say that it's A dash. It's always a tricky thing to include on the typing, so it's not really a apostrophe, it's a straight line. So complementary events are mutually exclusive, however, not all mutually exclusive events are not necessarily complementary. So some key things, remember this means or, it's the union of an event and its complement is equal to adding them together, and they should add up to 1. There shouldn't be any other possible outcomes of something and its complement. The other thing is the probability of getting something and something else is 0. You can't. It's a bit. You can't be not pregnant and pregnant at the same time. So the questions, really simply, an airline reports that 94% of its flights arrive on time. So on time is equal to 0.94. Always a good idea to convert percentages to decimals. What is the probability the flight will be late? That they should add up to 1. So the probability of late or probability of not on time, or the complement of on time, is equal to 1 take away 0.94, which is equal to 0.06. So not a particularly difficult question, but something you need to show. Key thing is with the notation, you need to explain what you're doing. Question 2 tends to be the way that they present complement questions if they're going to do them in this way by themselves. So an unprepared student makes random guesses for 10 true or false questions on the quiz. Find the probability that he gets at least one question correct. So we've got so the probability of at least one, so more than x being greater than 1, with x being the getting a question correct, then that's the probability x is equal to 1 plus probability of x is equal to 2 plus the probability x is equal to 3, and so on and so on. So how do we work out the probability of him getting 1 correct? So first of all, we need to think about what's the, so 1 out of 10 correct. So the probability that he gets exactly 1 correct is equal to the probability, but so the first question he gets correct, 0.5. And then times by the 9 questions he gets wrong. So the probability he gets it wrong, 0.5. Sorry, I didn't mention, so true-false questions, so it's a 50-50 chance he guesses the question correctly. So it's 5 to the power of 9. But then also, that's only if he gets the first question correct, but it might be that he, oh no, it doesn't matter the order, so we don't need to worry about timing it by 10. And then we have to, for the next one, is going to be 0.5 to the power of 2 of getting 2 questions correct times 0.5 times 8. The 8 questions he gets wrong. And then we go on and carry on, and we have to add all those together. Now, you might be thinking, what's that got to do with the complement? Well, the complement sometimes makes the question a lot easier. So the complement of the probability that he gets more than 1 correct is the probability he gets none correct. So I'll say that again. The complement to the probability he gets more than 1 correct is the probability he gets none correct. So we could work out probability x is greater than 1. Hang on, I've made a mess of this. I'll tell you. So the complement of x is greater than 1 is x is equal to 0. So in other words, the probability he gets 1 or more correct, the opposite is he gets none correct. And we can take that away from 1. Now the reason why that's helpful is that working out the probability he gets none correct, so he guesses all 10 wrong, the probability is 0.5 to the power of 10, which is 9.766 times 10 to the power of minus 4, so really, really small. And if I subtract that from which is 0.99902, so a really high probability that he'll get at least 1 correct answer. So sometimes those complement questions are hidden. It's much easier to find the complement than find the other one. Sometimes there's an infinite number of, so this one question was limited to 10 questions. It might be a scenario where there's an infinite number of values so that you could go for, like, so how many questions would he have to complete in an hour or whatever, then finding the complement is much easier. So finally, to summarize what we're talking about, two events can be written as A, B, or then we use the union. A and B is written with the intersection sign, and then we have the rules there that if if an event and its complement should add up to 1, and also there's no overlap, they're mutually exclusive, the A and the complement of A should add up to 0. Okay, go to the lesson page, there's a worksheet for you to complete, and if you need to, watch that Dr. Nick video again, please.